Hello learners, welcome to Education Online program. I'm teacher Willa Lucia. So in our previous lessons we've been talking about the gas laws. We looked at the Boyle's law, the Charles law, and then we have one other law under that, which is the pressure law, and it is what we shall be looking at today. This is the pressure. Just like in other laws, you see that the properties of the gases, at least one, was kept constant when verifying that law. It is going to be the same case with the pressure law. So you see that in Boyle's law we had the temperature being kept constant. Then we came to Charles' law where it was the pressure that we kept constant. Then this time round, what shall we keep constant? Here we have the volume, which is kept constant. So you see that the pressure law was also found by a scientist called Joseph Louis. So it was in 1808 when he tried to study the relationship between the temperature and the pressure of a gas. So we are going to see that because during his study he kept the volume constant. So how did he keep the volume constant? We shall also see that. So Louis stated that in pressure law we are saying that the volume of a fixed mass of a gas is kept constant, but then the pressure and then the temperature are directly proportional to each other. So if it's like that, we shall have it as our pressure, which is directly proportional to the temperature. So if it's like that, before we come to the mathematical, let's try to write that down. The pressure of a fixed mass of gas is directly proportional to its absolute temperature at fixed volume. So meaning that when he tried to get the relationship between the temperature and the pressure of this gas, he made sure that the pressure at that point has not been varied, but then he kept on varying only the temperature and then recording the pressure at this various temperature. So mathematically we can say that we shall have our pressure, and they're saying it's directly proportional to the temperature. So if it's like that, remember we have something that is constant. This one here is constant. We shall have it as constant volume. So if it's like that, we need to introduce the constant of proportionality in order for us to eliminate this symbol and introduce the equal sign. So we shall have it as our pressure from our product of pressure and then the volume we are saying is equals to constant. That is from Boyle's law. From Boyle's law. So if we are saying it is constant, and in Boyle's law we say that it is the temperature that is constant, so we shall have our pressure times the volume is equals to the constant, which is the temperature. So if it's like that, but in this case here, we did not keep temperature constant. We kept on varying the temperature and the pressure, but then we kept the volume of this gas constant. So instead of us having temperature as the constant, we shall introduce our volume as the constant there. Then how can you introduce it as the constant? We make it the subject. So we shall have it as our pressure divided by the temperature will give us the volume, which is the constant. So this is the Boyle's law. So if we have it like that, remember we said we keep on varying the pressure and the temperature. So you see that at the start, the pressure of this gas can be different from when the experiment is ending. So you see that there will be difference. Instead of us having only one, we kept on having various values of this pressure. So we shall have our pressure 1 and then the temperature 1, which will give us another value that we shall record of our pressure and then the temperature at that point. If we keep on varying the temperatures and the pressure, that means that we shall keep on having such equation, but then it will be constant. You see that? Meaning that this is the pressure probably at the start, the pressure and the temperature at the start of your experiment, and then you reached a point where you attained this pressure, which is now known as the pressure 2 and the temperature 2. You also continued and then gained this final value of pressure and temperature, which we are having it as a P3 and P4 and T3. So you see that when you keep on varying, you shall be getting different values there. So you keep on adding just, because it will just continue giving you a constant. So this is the formula of this is the mathematical expression of the pressure law. So now let's look at how we can verify this pressure law in the laboratory, or you can also try at home. So what do we need to verify? So you see that let's have our verification of pressure law. So we shall need a Boden gauge. Why do we have to include this when we are carrying this experiment? This one is to help us measure the pressure of the gas. So we need a thermometer, because how would you know that this is the temperature the gas has already attained? You cannot know that if you've not measured. So we shall need the temperature, which can be used to measure the thermometer for measuring the temperature. So how do you vary the temperature of this gas? You vary the temperature of the gas by checking the heat energy you've introduced. So we shall need the heat source, or you can say source of heat. So if we have that, you have this, but do you have the gas? No, we need a flask. Why do we need a flask? This flask is to help us we shall trap the air in the flask. So how do we connect the flask to the gauge? because you don't just put the gauge just right on top of the flask. So we shall need a tubing. So this tubing here should be as short as possible from the flask to the gauge, so that we do not experience some losses. Maybe the air escaping from the air escaping when it is supposed to, when you're supposed to read the pressure. So how would we arrange this apparatus? So let's see how we can connect all this. We shall need, the first thing we shall have here will be our flask. So if we have the flask, there is our flask. So in this flask, we trap the dry air. Let the air not be moist, but then dry. Because if it is moist, what will happen is that it will reach a time where it will do what? When you increase heat and the gas is moist, you will see that it will do what? It will escape as what? As steam. So we need dry air in the flask here. So we're saying that we shall connect a tubing from the flask to the gauge. So the gauge is the instrument for measuring the pressure. So we shall have our gauge right here. It has scales. This one we cock it so that the air does not escape from the flask. So here we already had our the dry air. So when you trap the air and then connect the tubing, we say this tube should be as short as possible from this point up to that. Don't mind here, it is just a diagram. It looks a bit longer, but then in real situation, it will be shorter than what you're seeing on the whiteboard. So you see that when you have your experiment like this, we need the thermometer. So how can we vary this? We shall have liquid. We are going to put the whole of this flask into hot water. So we shall, we get a can and then add hot water in it. When you fill it with hot water, make sure it is not very full, but then the water should at least be around here, up to the neck of our flask. So this is the water. We are still lacking our thermometer. We shall fix it at any point. It can be here as long as it is inside this can. So assuming this is our thermometer, right here. So you set your experiment just like this. So if you have it like this, you fill the water here so that it can at least reach the neck of your flask. So introduce the heat source. You try now to heat the can, because when you heat the can, it will reach a point where the water will also start absorbing the heat. So when it is absorbing the heat, meaning it will keep on varying its temperature here. So this varying temperature will be read from the thermometer. So at every stage where you're varying this temperature there, you will read the pressure the air is exerting from your gauge. So when you want to read this pressure, the value of the pressure, you make sure you first stop the heating, so that when you stop the heating, that means that you're going to maintain the temperature constant at that point, because it is the pressure at that particular temperature that you want to read off the gauge. So when you read that, you continue again varying. So, but as you're reading that, when you're doing your experiment, don't forget to be stirring the liquid, because the stirring of the liquid will distribute this heat, the energy, throughout the can, so that each and every part of this liquid will be producing the same temperature. So as you're stirring, at every point, when you get the temperature and you want to read the pressure, you make sure you first stop the heating. So when you get your pressure 1, then you get the temperature of that liquid at that point. Here what we are saying is that the volume of this gas has not been changed. So you see that if you do not change the volume of the gas, that means that this container, the flask here, we maintain it to be constant. So the pressure, because every time you increase, there will be increase in this pressure inside here with the temperature. But then if you do not increase the volume of this of the flask, what happens is that the air will increase in volume, but then it is going to be occupying just this small part, so keeping its volume actually fixed at the same time. So you see that when you also increase the temperature again, you read another value of pressure, let us say maybe pressure 2, and then the temperature at that point, we take it as T2. You continue with that until you get different values to help you in plotting a graph for your experiment. So during the plotting of the graph, what do you plot? Remember, in our experiment, we've been only reading off the temperature from the thermometer and then the pressure from the gauge. So that means that those are the 2 measurements we're going to be taking. So our plot, during the plotting of our graph, we shall have only the pressure values against the temperature values. So how will our graph look like? So you see that during the plotting of your graph, it should be at least the graph should, when you extrapolate it, let it move from the origin. If it's from the origin, I mean from the 0 point, let's something like this. At least we should have, on this axis we shall have our pressure, and then we have the temperature there. So our temperature, we are measuring it in Kelvin, and then we have the pressure in, you can measure in centimeters. We can measure our pressure either in pascals, or you can measure it in atmosphere. So you see that the graph, during the plotting of your graph, using the values you attained from the experiment, you should be getting a straight line. So the straight line, when you extrapolate it, let it come from the origin. This is the origin, I'm saying, where these 2 axes meet. So this one will give you the origin of your graph. So from here, it should be giving you a straight line. Why? Because with Charles' law, we are saying that the pressure is directly proportional to the absolute temperature. So meaning that when you double up the temperature, the pressure is also doubled up. So when you reduce the temperature, the pressure will also be reduced to that rate. So you see that these two actually move with it, they move equally. So this happens with the Kelvin scale. But then you find that when you read off your temperature using the Celsius scale, what will happen? This is how your graph is going to be looking like. Your graph will have the absolute zero temperature. Why is it having the absolute zero temperature? Because at that point we are saying that the volume of the gas becomes zero when the gas is cooled. So you will have your temperature here, which is in Celsius, and then we have our pressure in atmosphere. So when you're using the Celsius scale, your graph will have a straight line. But then this time round, it will not come from the origin, but it will extend to a point where you get the absolute zero temperature here, which is having a value of negative 273. This is degree Celsius. We are saying at this point here, the volume of the gas is zero. So this is the difference between the Celsius graph and the Kelvin graph with the pressure law. So you see that when you're getting the slope, the gradient of the slope of pressure in the pressure law, this gradient right here will give you the gradient there will give you the constant. And then what is the constant at this point? With the pressure law, our constant is the volume of this gas. So now, if we know how to plot the graph and from values you obtain from the experiment, how can we put the mathematical expression of the Charles law into practice? Let's take a look at this example here. We're saying that the pressure of a gas in a cylinder is 15 atmosphere at 27 degrees Celsius. What will be the pressure? What will be the pressure at 177 degrees Celsius? Then at what temperature? Will the pressure be? Atmosphere. So now, if we have our question like this, they are saying the pressure of a gas in a cylinder is 15 atmosphere at that. So meaning that they have given us the pressure and the temperature of this gas at the start of the experiment. So we can give it the P1, which will take the value of the first temperature from the start of the experiment, that is 15 atmosphere. And then we have the temperature at the start, which we have it as T1, 27 degrees Celsius. What will be the pressure at 177 degrees Celsius. So we have the temperature at the end of the experiment given to us as 177 degrees Celsius. But then we need to know the pressure at that instant. So to find the pressure, we shall apply the pressure law, where we are keeping the volume of our gas constant. So the pressure law is saying that we shall have it, we are saying that our pressure 1 divided by the temperature at the start is equal to the pressure at the end of the experiment dividing it by the temperature at the end of the experiment, which will give you is equals to the constant. So we shall have our pressure at the beginning and then the temperature, which will give us the pressure there. We are having it as 15 atmosphere. So we shall have our 15 here, and we are dividing it by the temperature also at the start. But then here the temperature has been given to us in degree Celsius. We convert the degree Celsius to the Kelvin scale. How do we convert that? We shall convert that using the absolute zero temperature value, which is 273. So we shall get our 27. To get our temperature 1, we shall have the 27 in degrees Celsius plus then absolute zero temperature, which is 273. So if we add the two, what shall we have? We have 273 plus 27. So 3 plus 7 will give us 10. We have 0, carry 1. So we have the 7 plus 2, which is 9, plus 1 will give us 10. We write 0, carry 1. So we have 1 plus 2. This will give us 3. So at the pressure of 15 atmosphere, we shall have the temperature as 300 Kelvin. So the second pressure also has been given to us using the Celsius scale. We go ahead and convert it to the Kelvin scale. So we shall have our pressure 2, which will give us 177 plus 273. This is in Kelvin. So we have our temperature 2 as, we have 273, and then we are adding 177 onto that. This 3 plus 7 will give us 10. You write 0 and then carry forward the 1. So we have 7 plus 7, which will give us 14. 14 plus 1, which is 15. We have 5. We carry 1. We shall have our 2 plus 1, which is 3. Then plus 1, which will give us 4. So we shall have here as 450 Kelvin. So you make sure you convert your the degree Celsius to the Kelvin scale. So now if we already have our Kelvin scale as 300. So we shall have it here as 300 equaling to our pressure 2, which is actually the pressure we want to find, and then we have the second temperature, which is the temperature at the end of the experiment as 450. So we shall have our pressure 2 that we don't have, dividing it by the 450 Kelvin. So now we cross multiply. We shall have 300 times P2, which will give us here 300 times the pressure 2 equaling to 15 times 450. So we shall have 300 and pressure 2, which will give us, if you're multiplying that, we have 450, and then we are multiplying it by 15. So 5 times 0 will give us 0. 5 times 5 will give us 25. We write 5 carry 2. We have 5 times 4, which will give us 20, plus 2 will be 22. We have 1 times 0, which will give us 0. 1 times 5, this is 5. 1 times 4 will give us 4. So we add. We shall have 0. 5 plus this plus 0 is 5. 2 plus 5 is 7. Then 2 plus 4 is 6. So we shall have our 15 times 450 as 6,750. So now we divide through by the coefficient of the pressure to give us the value of the pressure. We have dividing it by 300 and then dividing it by 300. So this will cancel with that. We shall have our pressure 2 will give us, now this will cancel with that. We have now the, instead of us cancelling, let's first go direct and divide it. So you see that 3 will divide 6 how many times? You have 6, 750. We are dividing it by 300. 3 will divide here once. 3 will divide 6 twice. Then it will divide 7 twice. Remainder will be 1. So making here to be 15. So 3 will divide 15 how many times? 3 will go into 15 up to 12, that is 4 times. 3 will go into 15, that is 5 times. So this one remains as our 0 there. So now if we have that, we still have 2,250. We are dividing it by 100. We can cross our 0, we cancel with that 0. So you'll be left with 225 dividing it by 10. So you see, you divide this and then carry a decimal point, meaning that our pressure 2 will give us 22.5 atmosphere. So you see, at this pressure, at this temperature of 450 Kelvin, we shall have a pressure of 22.5 atmosphere. So we have, at what temperature will the pressure be? 10 atmosphere. So now we have the pressure. We have the pressure here, which is 10 atmosphere. That is our pressure second we want to find, which is 10. But then this time round, it is the temperature we do not have. The second temperature, if you see that at what temperature, so they want us to find the temperature when the pressure is 10 atmosphere. So we also apply our pressure law, where we are saying our P1 over T1 will be equaling to our pressure at the end and then the temperature at the end. So we shall have our pressure here is, from the beginning, is 15. We are dividing it by the temperature at the start, which we had it as 300. So we have it equaling to, this time we have the pressure, which is given to us as 10 atmosphere, but then we do not know the temperature at that point. So if we cross multiply, we shall have 15 T2, which will give us 300 times 10 will give us 3000. So now we'll divide through by 15 by the coefficient of t, and then here by 15. You'll see that your T2 will be equaling to what? When you divide 15, this by 15, 15 goes here once, 15 goes into 30 twice. So we shall have it as 200. But what are we finding? Remember, it is T2. Don't forget the SI unit, which will be Kelvin. So at the pressure of 10 atmosphere, we shall have a pressure of 200 Kelvin. So you see that whenever you reduce the pressure, the temperature, whenever you reduce the temperature, the pressure is reduced. And when you increase the temperature, the pressure is also increased. So you see that this one verifies for us the Charles law. You see, because this increase in pressure is because when you increase the temperature, what happens? The bond between this between the molecules, they weaken. So these molecules will be moving randomly and very fast, but then in a very confined container. So they want to expand and move further, occupy further area, but then the area is being compressed. So that will create a very high pressure at that point because of their colliding with each other and then the wall of the flask. So this is more about pressure law. So we shall continue with our topic in the next lesson, but then it won't be pressure law this time round. We shall have the equation of state in our next lesson. Thank you very much for attending. We shall meet again in the next lesson.